We're going to talk about something that happens all the time in games. An NPC is wandering around, minding its own business, and it happens to encounter the player. And if it knows what's good for it, it's going to run away. So let's talk about the concepts behind and how to make the AI do that. Now, I'm going to explain the basic concept of this whole video right now, and if you know how to use Unity, you should be able to get this and be able to go into the editor and do this on your own without any help. You won't have to copy anything I do. Now, imagine that we have a line, we have the x-axis, we have an object at position 0, let's say it's our NPC, and we have the player at position 1. To get from 0 to 1, the direction between my chicken and my fox is positive 1. Now, if I want to get to the fox, I have to go plus 1 on the x-axis. And if I want to get away from the fox, I need to go minus 1. That's the whole idea of this entire thing. I'm going to give you guys one more example of how this works. We're going to do this on a 2D plane, but it might as well be a 3D world. We have our two characters. The line between them is the direction from one character to the next. In order to go in the opposite direction, all we have to do is negate that line. That is, create a line in the opposite direction by subtracting that line, subtracting that vector. Now, if you didn't understand that or you want to know how to do it in Unity, keep following along. All right, I'm going to start in a new scene here, and I'm going to first add a plane, and that'll be the space that my characters walk on. I'm going to amplify the size of it, so it's going to be, the normal plane is a 10 by 10 square, so this will be a 100 by 100 square, all right? Now, in order for my characters to walk, I'm going to want them to go ahead and have pathfinding, and I can do that easily by adding in a Unity nav mesh. Now, if you don't know how to do that, you go to Window, go to AI, and then click on the navigation, and then you'll get a new tab called the Navigation tab. And then by clicking on this object and setting it to navigation static, and then baking the scene, you'll have a nav mesh, okay? And everything that's blue is something you can walk on, all right? Now I'm going to want some characters. I'm going to go ahead and pop in a new game object. I'm going to call this NPC, let's say. I'm going to reset its transform so it's back at 0, 0, 0, right in the middle of our ground plane. And then I'm going to pop a capsule onto that, and I'm going to bring it up by 0.8 because I think the size of these is 1.9. No, okay, so it's 2 meters tall. So if you just set the position on the Y to 1, it'll be above the ground. Now I want to know what direction it's facing in, so I'm going to add a cube and set these as its glasses. So let's bring that forward, and I'm going to resize it. The X, set that to 0.5, 0.1 on the Y, and then 0.2, 0.3 on the Z. And I'll set that as his eyes. I'm going to bring in some new colors. I've already got materials made, but I'm just going to use basic materials. Doesn't matter what you use, I just want to be able to differentiate this guy from the rest of the scene. I'm going to duplicate that by clicking Control D on Windows, and I'll make this other one red. So one is going to chase the other. Let's start with the easiest thing and make our red guy chase our green guy. Now, we have our navigation, we have our nav mesh, okay? In order for that to be used, we want to get a nav mesh agent onto our NPC here. Okay, so all I'm going to do is add a nav mesh agent to this guy, and then I'm going to add a new component. Let's just call this chaser. And we're going to add a new script, and I'm going to go ahead and click directly onto that script. So I'm going to click on that script, and I am going to add, first I need to bring in the namespace in which the the nav mesh agent exists. So I'm going to create a serialized field to a private nav mesh agent. I'm going to call this agent and default it to null. And then I'm going to create a target for him to chase. So a target will be a transform reference, and let's just call it target, and this will be a member variable that's a member of the class. And let's just say that if I forget to set up the agent in the inspector, so if the agent is null, I'm going to try and get the component from on this object, and I'm going to pass in that agent. And by using that out keyword, I'm saying that this method, this try get component method, has to do something to agent. So if it has the agent on this object, it'll set it, and if not, it'll be null. And I'm going to say that if this continues to be null, then I'm going to say debug.log warning. My character, or my chaser here, the name of this object needs a navmesh agent. Okay. And now what we want to do is create a method called move to target. And this is just going to move our navmesh agent, excuse me. So let's call that move to target. And this is going to say that our agent is going to set destination as the target.position. And the reason that I'm doing this on every frame, that is the reason that I'm setting the destination and making sure he's not stopped, is stopped, should be false, excuse me. So this means he's moving, he should move. So what I'm going to do in update is check that I have a target, and if I have a target, then I'm going to move to target. And I want to do that on every frame because if my guy is moving, if my target is moving, then I have to continually reset that destination. Okay, so let's make sure that that works. Let's test it out in the scene here. He has the chaser. Let's make sure I set the target as the green guy. And I'm going to press play, and he's going to move to the green guy. Okay, let's just make sure that we're in the scene view so we can move these people around. Perfect. Now, if I set my navmesh agent's stopping distance to 1, for example, he won't try to be on top of my green guy here. Did that work? It did not. Did I set it to 1? Let's try 2. Maybe that has to be set before the game starts running. No, okay. I guess 2 is the better number. Okay. So let's change that. We're going to change the stopping distance to 2. And now we're going to create a runaway script for our other NPC. And let's just call that runaway and create a new script. And let's enter that script. Now, let's let this compile. Now, before we get into the actual running away, we're going to do a little debugging. We're going to do a little gizmo drawing. On draw gizmos, okay. We're going to draw a line between our two characters, between our two guys here. Let's just call this a red line, and we want it to draw a line from my position, from this object's position, to another position. And the other position is the guy that's chasing me. So let's add a transform and call that chaser, the person that's chasing me. And I'm going to say that I'm going to draw a line from myself to the chaser's position. And we'll see that in the inspector here. In the editor, excuse me. All right, now I need to have a chaser. Otherwise that won't work and we'll throw errors. Okay, so we see that it's drawing a line from me to the let's call him the bad guy. If I press play, that'll just continually happen as well. Perfect. Now, we need to get the direction, and that direction is actually just that same line, okay? So what I'm going to do is go ahead and I'm going to create a new vector 3, call this direction, and I'm going to say from chaser.position minus my position, that's the direction. What I'm going to do for the draw line now is I'm going to say draw a line from my position to my position plus the direction. And we'll see that it's drawing the same exact line. Yeah, nothing changes, okay? And everything's all set up the same way, all right? So we don't have any errors, and it's still drawing that same exact line. Now, what we want to do is be able to say that we could change that direction by some scalable amount. And what I mean is, I don't always like let's say if I want to run away in the opposite direction, I don't want to run away these 4 meters or whatever it is. I might want to run away 1 meter or run away 100 meters or something. So what I want to do is normalize this direction. So what I'm going to do is put parentheses around this original direction that I had set up. And what this does is direction dir becomes a 1 value. Okay, so this is direction will sum all of its components, it's x, y, and z, and it'll be a value of 1. So if we want to get the magnitude of direction, we can do magnitude, and that'll be 1. Okay, and we'll print that just so that we see that that's true. Okay, so you get a normalized direction. We're going to get its magnitude, its length, and we're going to print that out, and that's going to be 1, I guarantee you, okay, or close to 1 because it's floats. So let's take a look at that. And sorry for kind of skipping around. Instead of being a line from my guy to the other guy, it'll be a line in that direction, but with a maximum length of 1. So we'll see that line change, and it's much smaller, right? It's a length of 1 now. Okay, and we can see that our console is printing out the length of that normalized direction now. Okay, and it's 1 or very close to 1. So that's perfect. Let's change this now. Let's make this so that our guy actually moves in a direction. So we can keep all this stuff. We can actually change this to update, and then let's just redo it from scratch. Sorry, guys. Okay, so we're going to bring in our using Unity engine.ai, and this brings us our nav mesh agent. So I'm going to put that at the top here. Really, this doesn't have to be, this isn't the ideal way to do this, because you can tell I'm doing the exact same thing on this guy as I did on the last guy. I have a transform, which is basically a target. I have a nav mesh agent. Really, I should be doing this as kind of a movement class as opposed to a runaway class. Like this behavior, the behavior that we're going to create here should be something apart from the movement. So that's something that you can do on refactoring. Okay. So let's do that same exact move to, well, actually it'd be better to have a method called move to position void, move to pose, vector 3, pose. So we're going to move to a new target, and we're going to set our agent's set destination to that position, and we're going to make sure that our agent actually moves to that position. Okay, and we'll do that on update. On update, we're always just going to be moving to a new position. Okay, so let's say that if we have someone chasing us, if chaser, let's actually try this. If chaser equals no, we're just going to escape from this method. Okay, we're not going to do anything if we don't have a chaser. Otherwise, we're going to get a direction to that chaser, and we'll actually create that as a normalized direction. So chaser dot position minus my position dot normalized. Okay, so we could actually rename that norm dir normalized direction. And what I want to do is say how far away I want to get away from my current position. So I'm going to set up a private float, and we'll call that displacement dist, and we'll just set that to 5 to start. Okay. So what I want to do is move my guy away from his current position in this normalized direction. Okay. Let's start with that. So to start with, we're going to be moving toward our enemy. Okay. So I'm going to start with my position, and then I'm just going to say plus normdir times the distance that we want to displace. So he's actually going to move toward the enemy, 5 meters towards the enemy, I should say. So let's start them off, let's start them off a little bit further apart so we can see what my guy's trying to do. Good. Yeah. Let's go into scene view. He does not have a nav mesh agent. That's the problem. Okay. There we go. He needs a nav mesh agent. We can just put that right in there to start with. Okay. Now let's see what he does. He's moving towards our enemy. Perfect. Now, in order to get him to move away from the enemy, what do we have to do? Okay, so this is a positive value, right? This direction is a positive value, or we're adding to that direction. What's the opposite of positive 1? Negative 1, okay? If we want to move in the other direction, we're just going to subtract that. All right, so now we're going to see him move in the opposite direction, and these guys will just chase each other around. Well, red will chase green around all day long. So let's go back into scene view and watch that happen. So you can see that red, because they have the same speed, they're never going to catch each other. Well, I guess what might happen here is they'll get to the edge. Okay, so he'll pathfind for the next closest thing. No, he'll just get stuck in that corner. Okay, so that's not super ideal. What I can do is change the direction. I can add an angle to the direction. So let's say, for example, I wanted to add an angle of 45 degrees. That'll go to the right, okay? And that's going up the up axis, okay? So what I'm going to do is change normalized direction by this. So what I have to do first is multiply by the quaternion, or have the quaternion first and then multiply it by our direction. So what's going to happen is he's going to always move on a 45-degree angle to the right. So let's take a look at what happens here. So he's always moving away from the guy that's chasing him, and now he's going to be doing it to the right. So let's take a look at how that looks. Where's our guy? So he's going to be going in circles now. So he's always going to the right and away from our guy. Let's try to make, see when they catch up to each other. Okay, so, okay, he caught him. All right, my expectation was that they would never catch each other. But it looks like, let's see what happens if we add a little speed to our green guy. Let's see if that circle gets a little bit bigger. Let's add a lot more speed, sorry. Okay, so he's just going to be going in circles around our red guy. And that's pretty much what we expect to happen. So we'll take a look later on at how we could make better runaway mechanics. But for now, that's pretty good for getting these guys to run away from each other. So if you want to run away at an angle, you can use this quaternion angle axis, and then you multiply it by the angle. You give the angle that you want to go to the right. It's going to be a number below 180. Let's see if this works. Let's see if I'm right about that. So 360, 315. Let's say it's 315. So I think this way he would move to the left. So he should move 45 degrees to the left if he's doing this. Let's see if he runs away to the left. Our green guy. He's running away now to the left. Okay, so let's make green a little bit faster, and let's make red a little bit faster as well. So yeah, these guys will just chase each other around all day long. One's faster than the other, so ideally they're not going to catch up with each other. And then you can use, like I said, you can use quaternion angle axis in order to make them move from one side to the other. Be careful with giving that a random value. So here you might be tempted to give it a random value, but if you, for example, give it a random value between, let's say 0 and 360, well, 359, what's going to happen is well, maybe you'd like this, but he's going to do like a curvy movement. So instead of going to one side or to the other side, he's going to move from side to side, but in a very jerky way that you probably aren't going to like. So let's see if that even works. All right, so that's not even, okay, let's try it if he's faster. Let's try 25, something ridiculous. All right, so yeah, that works horrifically. All right, what you might try is, for example, if you want him to move to the right, you'd say a random value between 0 and 179. And he might be going so slow because of his angular speed on the nav mesh agent. So let's take a look at this. He should move to the right always, but it'd be like kind of a jerky, yeah. So let's try to increase his angular speed. Let's say his angular speed is a lot higher, and let's increase his actual speed. So yeah, he'll move kind of, well, it's not bad. So yeah, you can try that. If you want to do random, make sure that you're doing it on only one side. So for example, if you want to move to the right, it's 0 to 180. And if you want to move to the left, it's 181 to 360. Or excuse me, 180 to 359. So to finish this thing out, let's take a look at how I would refactor each of these classes, the chaser and runaway. I would extract all of the movement and put it into its own class. So I've got this class called the nav agent mover here. And it's just a class where you do movement. So you pass in some movement orders, and the object that this is attached to will do those movement orders without regard for which movement orders, without regard to their priority. So whichever move order came in last is the one that it's going to execute. Okay. It's got this iSpeed thing and some other methods that you didn't see, but that's just so that other objects around this can check how fast this one goes, and then so that we can see if we've arrived at our destination or if we're close to it, and then to order it to stop. The changes I made to Chaser are a lot because I want to give you guys an idea of how you might do this. You can see that I've added this iInstincts implementation of an interface. So let's take a look at this. iInstincts has two methods. One is become prey of some transform, and then another is to get the integer predator level of any animal in the world. So what I've done is created what I'd say are foxes and chickens. I've tagged them as animals, and I've given them sphere colliders and rigid bodies so that they can be triggers. So if you give it a rigid body and you change this to is trigger, then you can check if there are other objects around it. All right. And once something enters the trigger of the fox, if it is a weaker animal, let's say that the other animal has a lesser predator level and it's going slower than its current target, or it's closer than its current target, then it will target that animal. That way I don't have to directly say to the runaway class, hey, I'm chasing you. Okay. So this is one way to sort of keep things uncoupled. And then in the runaway class, sort of similar, I've got the on trigger enter. If the other collider is an animal and it's a greater predator than I am, then I need to run away. Okay. This vector 3 dot is just checking if it's looking at me, and if it is looking at me and it's close, then I want to run away from that. So you take a quick look at how that is working here, and you can see that when the foxes get close to the chickens, they'll kill them, or they'll eliminate them from the scene. And well, it's got its bugs, but the chickens, while they're not being chased, will just idle around. See if I can move these guys. So that's just an idea to give you guys an idea of how you might be able to implement this.